Okay, let's try again. This time we're going to solve the same equation, but instead of using bisection in Newton's method, we're going to try the secant method. So why? How should I know? Anyhow, let's call this secant solve.m. Yes, please do create it. Okay, so solve the equation x cubed minus 3x plus 1 equals 0 using secant iteration. And we want the root between 0 and 1 as before. So as before, I want a function which takes a single variable x and produces x cubed minus 3 times x plus 1. Okay, and I'm going to start off with not one, but two initial guesses. The guesses 0 and 1. And I need two initial guesses because I'm going to draw a secant line in between them. So x of 1 is 0, that's my first initial guess. And fx of 1 is going to be f of 0. And x of 2 is 1. Fx of 2 is f of 1. Okay, so these are my initial guesses and function values. And now I'm going to try to refine. So secant iteration steps. Okay, so again, I'm going to be a little bit unsystematic and just do 10 of them. Okay, and let's see, what's the equation for the secant line? Well, I know that the slope of the secant line is going to be the difference in, I'm starting at k equals 3. The slope is going to be the difference in f values divided by the difference in x values. Now, which f values? The f values from the previous two iterations, and the same with x values. So at k equals 3, for example, I'm going to look at the difference between f of x2 and f of x1 divided by the difference between x2 and x1. Okay, so let's just code that. So f of x k minus 1 minus f of x k minus 2 divided by x k minus 1 minus x k minus 2. Okay, and we've got now the equation for the line is x minus the low end, which is x times k minus 2. And we're solving this for xk. Okay, so that's the value at point xk is what we want, and that's going to be that times the slope plus f of x k minus 2. Right, and we want to set that equal to 0. Okay, so now let me do the algebra on the fly in comments. Right, so we subtract. Oops. Okay. So make a copy of it so that there's a version that I can do manipulations on. So first thing we do is to move our f of x k minus 2 to the other side. So we subtract from both sides. Okay, and now we divide both sides by the slope. And now we add xk minus 2 to both sides. And voila, there's our expression. Okay. Now I'm a little bit nervous about this because I can see that there's a potential as I get convergence that these numbers will come very close to each other and I'll get a poor estimate of my slope. But that's what we call failing by succeeding. If that happens, that means that I've actually converged. Okay, so I won't worry about this because this is a toy code anyhow. So now I'm going to print out the current step number, and I'm going to see what the change is and what my current residual is. So that's going to be two floating point numbers. So I want my step k, and then after that I'm going to print out the current residual, fxk. I better evaluate that, hadn't I? So fxk is f of x of k. And in addition, I would like to know how much I've moved. So xk minus xk minus 1. So both of those numbers should be going to 0 as I move along. So print information to diagnose convergence. Okay, so if I've done everything right, this should be a working secant iteration. Let's run it and see what we get. Okay, so we started off with a residual on the order of 10 to the negative 1, that's fine. Then 10 to the negative 1, okay. 10 to the negative 2, 3, 6, 10, 16. Okay, so this certainly looks like it's converging. Right? So now that's how you do it. We've written an iteration using the secant method to solve a particular nonlinear equation.